Hi, this is Tim, and welcome to Talks with Tim Live. Tonight, we're going to be going over my first PLC program. Actually, I need to correct that, though. This is my second PLC program. Before we even get into that, I've got my just video expert person over here, Michael. And Michael, is everything looking good over there?
Yep.
All right, so we're looking good. Hopefully I keep an eye on chat this time. He'll keep me straight when things go wrong. And yeah, we'll hopefully have a really productive time. Now, a little bit about this. I've intentionally not looked at this program thoroughly because I kind of want to think through it. And when you have questions, put them in the chat. And yeah, we'll kind of walk through this together and see what we could have done better, what worked, what was horribly bombed in this. Okay, so yeah, this is actually my second program. About 2 years before this, I wrote a program on, I want to say it was like an Aeromat Nasus. I can't remember. It just flashed into my head this morning. And it was 3 lines long, and it took me like 3 hours to program it, and I swore I would never touch a PLC again. So a couple of things there is, yeah, this doesn't come naturally to everyone. And it's okay if it doesn't, because yeah, for the next 2 years, I touched 0 PLC programs. In fact, I'll never forget, I did take a class. It was one of my engineering classes. And of all the things somebody posted today, it was kind of lifespans of different programs. And I had to write a program in Fortran of all things. And I remember the instructor, and he'd be like, we're going to figure out how to calculate this in Fortran. And then I was like, well, can I just use a piece of paper? And yeah, it just, software and computers were not natural. I really did not get into them, and that's okay. So if you think that, you know, if it doesn't come natural, it's not for you, then just hang in there. It may be just what you're looking for. Now, a lot of people will tell you that, you know, with years of practice, you can become a PLC programmer. I had a different entry into this industry. So before this program, I did have 3 hours of programming experience. And my dad was a firm believer that you could do anything if you set your mind to it. And all you needed was a good attitude and 100% effort. And so really, I went into writing this program with almost 0 experience. So this is the one that I've shared that I went and programmed at night because I had no idea what I was doing, and I didn't want everybody to know it. So yeah, everybody was leaving about 5. I would go in with my manuals. I had the RsLogix instruction reference, and then I had a second manual, and I can't remember which one that was. But I would sit there and I would read those manuals every night and work through getting this machine going. Now, also, this is before we actually had YouTube, obviously, and I'm trying to remember when this would have been around 1999, and Phil Malore over at PLCs.net, I think his was starting up about then. So that I did not know about that forum, but it may have been, but it was a very vacant place on the internet as far as finding information about PLCs. So, you know, manuals were your friend then, and I'm not so sure they shouldn't be a little more of your friend now. But yeah. One other thing, I had a much broader vocabulary at the time that I was writing this program, so I apologize for any colorful metaphors that we may find in it. I did find a few and removed them. But yeah, so let's go ahead and get started into this. And this is an RsLogix 500 program, and you can tell by rung 0 there, this had a DeviceNet card in it. Hey, Dan. Dan's in chat. Very nice to see you there. But so yeah, this is the scanner run bit, and so it probably is worth just stopping and looking at how the I/O worked on this system, because, you know, there were many contrasts between me and my dad, and one of them definitely was, if there was some latest and greatest thing, he was on it. So when we built this system, and it is fuzzy in my mind, but I think we ended up with Automation Direct scanner cards for DirectLogix 205 chassis. And the project got delayed a little bit because they didn't actually have them yet. So we had like the first scanner cards, or some of the first ones. Also, we had some Parker valves that were pure prototypes. I mean, they were clean, they were cool looking. But there wasn't a single other one on this earth. And yeah, there were no replacement parts if it went bad. And that was always kind of the way he did. And I was kind of on the contrast side, which just kind of made me that more, let's call it locomotive designer, that, you know, I don't get really into the latest and greatest bells and whistles. Usually I hit the old, more basic, more tried and true type things. But anyway, if we look into here and we go, well, first let's go to our I/O configuration. You're going to see that, yeah, this has only a DeviceNet scanner card in it. And this is a SLIC 503. And I'm going to go ahead and already ream myself right away. So my first issue I have with my program is, the last time I looked at this, it was over a decade ago. It was the last time I was connected to this machine and looking at it. It did have the same program in it from 20 some years ago. So that was cool. But if I go to my usage, I can kind of see where we're using some inputs. But I have zero documentation. Now, I do have documentation on what the input is, but what I should have done here is I should have documented these words as to where their location was, or where this is connected to. Because I can kind of guess today, these right here, start, stop, cycle, start. So these are definitely a push button station probably. I'm wildly guessing. So yeah, here I should have labeled this probably like main push button station, and probably node. And I do not know the node number. I'm just going to wildly throw in that it was node 1. But I should have documented something like this, and that would have helped me now 20 years from now. Also, this is before RS Networks, and there was some software before it that you used to configure DeviceNet. And I am not remembering what it was. So maybe somebody in chat can jog my memory as to what we configured DeviceNet with before we had RS Networks. Let's see. We have a question. How do you document where the card is? Oh, I guess you're kind of with the same question I have right now. So yeah, I have no idea where these nodes are. Now they're grouped. So I can tell that word 11, 12, and 13 was some node number on DeviceNet. And probably word 7 up here was another one. Now I can tell here that input slot 1. So when we're looking at this, this is I:, and then that 1 is the slot number. And then dot word, this is going to be the word number. So all of these 1s you see here, this is all in DeviceNet. And all this is accessible except for this top one. I think this top one, I believe word 0 was reserved for some diagnostics. I can't really remember. I hadn't dealt with DeviceNet in a long time. I definitely haven't dealt with DeviceNet on a SLIC in a very long time. But probably the same with the outputs. If we go here, okay, this is the DeviceNet scanner run bit. I remember that, had to be on. And we'll have to see where the malfunction alarm was used in the program, but we have something there. It kind of scares me as how I might have been using it. Okay, but same deal we have word 3, 4, and 5. They look like they were probably some node, but I probably didn't know at the time that I could document these words. I probably just thought I could document bits, and as we get further into it, we'll see. Or maybe DeviceNet Manager. That was the software before RS Networks. And boy, it wasn't very documentable. So I was getting ready to say maybe I had it documented in something else. Maybe there was a Device Manager file, but as I recall, it was not the most intuitive software. But that's, like I said, it's been a very long time. But all right, you're going to hear me say it throughout this, as yeah, documentation is so important. All right, the next thing that really makes me cringe right now is I have an MCR right away. And MCR is an instruction that is available, but let's just hope it was only used once. Because what an MCR is going to do is it's going to, well, let's just MCR, does F1 work in this? MCR, there we go. Is, yeah, it is going to, this output instruction, sometimes the zone control, is used to set up areas in your ladder logic where non-retentive outputs may be disabled at the same time. So what it's going to do is write a 0 to pretty much every OTE through a certain area of the program. Now, what I don't like about this, if I did it like I may have done it, is it can be really difficult when you're searching and finding to figure out what's in an MCR zone and what's not. So let's hope there's only 2 MCRs, because you'd have one to start it and one to stop it. So just going to hit Control F on that. And MCR. We find next, okay, this is this one. This is hopefully the end of it. And well, there is the next one. And there's the end of another zone. Oh boy, and there's another one. And all these are starting off the same MCR, notice. Cycle start. And there's the end of another zone. Oh gosh, and right behind it, what was I thinking right here? Okay, so now we're starting to have some issue with this. It's really, I end an MCR. Oh no, but this MCR goes off of something different. The other one was cycle start. This one is ready. Oh yeah, I should have, yeah, so this I really disagree with how I did. Yeah, I should have made some more of a permissive routine. Really, this should have been ready, and really, if that's all that's in there, I probably could have added ready to each one of them. All right, that's the end of that one. Oh gosh, and there's another one. We're back to cycle start. So it's going to be really difficult to read this and figure out why some rungs are showing on and my output's not on. And oh gosh, I don't know how many of these are in here. I might should have reviewed this program beforehand, but no, I mean, really, okay. Still, this program has ran for 20 some years, so it's not that it's horrible, but it definitely needs some work. Now already I'm seeing something more concerning, and I'm at rung 131, and I'm not halfway through this program yet, and we only have one routine here. And so this, so this program is 319 rungs long, and it does not have a single subroutine over here. So this should have been broken up much more than it actually is. And not just for length. I mean, there's nothing wrong with having 300 rungs in one subroutine. There's no deal there. But this should have been, the subroutine should have been used to kind of organize this code. And probably, because it kind of is coming back to me, I believe a few projects down the road, I saw one that had like 100 subroutines over here. And I'm like, well, what do the subroutines do? And they're like, we just use them for folder structure. I'm like, oh my goodness, that would be great. But so here, I should have, well, first we could rename this. So this would have been my main. And then it'll come back to me a little more as we go through it. But I think I saw a main sequence to go back up here. We got a main step. I probably would have called it something else, but I'm not going to change it too much. But I would have new routine. This would be like main step. And then looks like we have a feeding step. And then we have a paint step. Oh, then we have a gate step. Seems like there's some more, and we'll find them as we go. Okay, and then all I would need to do is, and I probably would do it, I don't know, let's just say this, yeah, I would leave the MCR there, and then I would bring a rung down, and I'd put a JSR in it. And this first one would be U:3, which is going to be ladder 3. And I would label that as main. Let's just call it main step sequence. And then, oops, why isn't it like that? What did I do wrong? Oh, it likes it fine. Okay. And then we'd have 1, 2, 3 of those. And this would be 4. This would be our feed step sequence. And this would be 5. Whoops, that would be paint step. And then this would be 6. Okay, and then as we go along, we would break this up. Now what's happening here, this is not changing the program in any way because these are all unconditional JSRs. Now let me make sure I'm clear. It's not changing the program, but as we move some things around, we could change the program scan execution. And especially with some of these MCRs and some other things we find in here, it could cause us some changes into how this program executed. All right, but let's look a little further before I shoot down my own program. But all right, we've already talked about the MCR. That was not a great thing. Okay, and then we have, looks like I'm resetting some things if we're not in auto mode or someone presses the cycle stop button. Okay, and we're doing the exact same thing again to hopefully some different things. Yeah, these are different. Why did I do this? Okay, the slick, I believe nested branches you can only have 4. Can I have one a branch? I cannot, but I can search for branch. And we can find branch general information. Well, this looks promising. There we go. So nested branches are limited to a maximum of 4. Now, if you're clicking icons around, this extend leg up and extended leg down is such a hidden thing that I probably just didn't realize this. Okay, so I have nested branches here. What I could have done is instead, now let's talk about nested branches. Nested branches is just dragging another branch down. So I could drag another one of these down. Now first let's talk about why this wouldn't work. Is if I move this one up here, actually let's just go and do them all, because really looking at this, what I really would want to do is I would want to group all these together like this, because they all have the exact same conditions in. So why not make them exactly the same? Oops, put that one in the wrong spot. Can I drag that out, or I gotta delete? Oh, get out of there. Oh yeah, now I'm really messing up. Let's just delete that, get over here, branch. Oops, already did 540, 51. There we go. So I would hope to be able to do that and then delete this. But when you hit verify, this isn't going to work. So I'm going to hit the verify button up here, and we're going to get an error. And it says branch nesting exceeds processor limit. So what we're going to want to do is, instead of doing this nesting, now why would we do nesting first of all, is you could actually have, which I'll leave one of these so we can show that. We could actually have conditions on the various nesting. So in this case we could say if auto mode is a 0, or we press the cycle stop button and make it a 1, then we're going to do these 3 things, but we want a condition on this one. Now if we extend the branch down, which there's no button for, there is a button for adding a branch, but there's no button here. There's no real intuitive way to extend this branch down, and I'm going to guess I did not know how to do it. But I can right click and I can extend that one down, I can extend that one down, I can extend that one down, and I think I can do it one more time. I think that gives me enough. And then I can start dragging these up. There we go. Now I'm going to leave one of these though. So I'm going to delete this one. Actually, no, let me get this working first so we can see that this would work. So this is exactly the same code. Now hit the verify button now, and it verifies perfectly fine because we have this extend branch down. Now let's understand why we can't do it. Is I'm just going to drag and examine if closed into this one. I hope I'm right on this because I'm really going on the fly here. And let's say I'm just going to use the exact same condition, as I'm pretty sure it's going to give us an error on this. Got to remember which processor. Nope, this processor does not. So in this case, this will function exactly the same as the nested branch. It seems like some of the processors you couldn't put anything in the branch output, but I could be completely wrong on that. But all right, so that verifies now. Okay, and then, you know, we've got some documentation that I can probably figure out. So we got some inputs for, you know, or this is an output for a malfunction and a mischeck. Seems like this machine had a carousel. Just a little bit about how it actually worked. I mean, this was actually a very complicated machine. So the part came in and it seems like there was an elevator that pushed the part up onto a chuck, and it would chuck it. And then there was a carousel that indexed around to 5 or 6 stations. And so it would hit one process, and then you had to make sure all the processes were done. And not always there was a part on them, so you had to ignore it sometimes. And it would index and keep going through, and it would shoot the part out the other side. So the mischeck, though, that was definitely probably we dropped a part on it. Oh, yeah, okay. Yeah, I got somebody in the chat here. Yeah, they also have had, you know, the extended branch. You know, that's one of those. I don't know why it's so hidden. Yeah, and maybe somebody can tell me, am I just like missing the obvious? If you're like used to icons, and I think it's the same thing in our Studio 5000. If you're used to icons and you're coming up here clicking, that's all you see is to drag that down and then drag that over. Yeah, I mean, who knows that little secret feature exists in the branch? But yeah, so all right, now let's get to this one because you know, I put out a video. It's been about a month ago now, maybe a little longer ago, talking about latches and unlatches in the control logics and compact logics. Hey, Mike, will you go kill that? And I got a lot of flack on it. People saying, do we really need to teach people about latches and unlatches? And I'm like, absolutely. I mean, if somebody doesn't know how to use something, then they're a lot more likely to use it wrong. So I do think we need to teach about it, but let's just evaluate this one and let's see how bad I did. So we have arm stop position. Okay, this is that carousel. So that carousel had to manually be put into position if it wasn't in position for whatever reason, emergency stop or whatever. And you press the cycle stop button. Well, I actually, we're going to get into that. I don't think latching is necessarily bad. I think there are a lot of people out there that use latches and unlatches when they don't understand program flow. And what you'll see, and I'm hoping I didn't do this, but you know, I was new. I mean, you got to remember, I had 3 hours of program experience when I wrote this. Is what you may see is that we scatter a latch and unlatch of this one bit throughout this program. And that's what's going to get messy when you're troubleshooting. And that's why, and especially troubleshooters will be like, no, don't use latches and unlatches. And let's just see how this one plays out. Let's see, did I prepare electrical schematics and cabinet layouts for this project too? Yeah, I did. And I did look for them, but you know, this is 22 years ago. It was 99. I couldn't find them. Yeah, so I do not have them. I even looked for pictures of this, but you know, this, again, think about the year. It wasn't like everybody just grabbing a hold of a camera and taking pictures of all their panels then. So I have 0 pictures of this panel, or maybe I do. They're probably in a shoebox somewhere if I do. But yeah, I'm going to butcher some of your names, but yeah, AP there, you're right. It does get difficult to track in a large one, but okay. So right now we've got to be in position, and we cannot be in cycle stop mode to start it. That kind of makes sense. But okay, then we're going to latch the cycle start and we're going to unlatch the cycle stop. Now, am I doing the same thing here? I hit the cycle stop. Okay, so I do have a little bit of an issue right here. Is I am going to latch the start button here and unlatch, I'm going to latch the cycle start and unlatch the cycle stop. And here I'm going to do the opposite. So really anywhere here that I'm looking at the cycle stop, I could have looked for the opposite on the cycle start bit. Now looking at this, at least so far, it does not look like this would be horrific to change into a basic seal in. Hey, will you take that back up? So let's see. All right, first let's see where all this is used at. So we're going to cross-reference. And, oh, look at there. Okay, so I will not give myself a lot of flack here. Is I have an output latch and an output unlatch, and they're both used in the exact same rung. So this is if you're going to do a latch unlatch, this is as clean as it gets. I mean, I'm using it a gazillion places throughout this program, but that latch and unlatch is only used here. Now, let's check the cycle stop and see about it. And okay, and look at there. So this is an unnecessary latch and unlatch, but you can't knock it. But let's just copy and paste this rung and see what we could have done differently. So we'll make rung 8 the new, rung 9 will be the original. Okay, we're looking for a cycle start being pressed, okay, and not the cycle stop. Which really, and here's where I may not be able to follow this even quick enough. This is a different cycle stop. I just caught that. Where is this coming from? Oh, okay, no, it's down here. I just missed it. So cycle stop, tire and painter. Okay, well, if we're not pressing the cycle stop, because the cycle stop's coming from right there, then we'll never have the cycle. Yeah. So this actually is unnecessary. So we could actually, yeah, let's see. So the first thing to tackle is B36. Is mainly I need to use the opposite of the cycle start wherever I was using it. So if we copied that and we go to cross-reference and okay, and I'm only using it 4 places. One's in here. We have rung 263. Oops, now it's 264. Okay, so in this case, this should have been cycle start, and I could have changed this to that. Same here. And changed that to the opposite. And then there was only one other place for 121. And then where is 120? Here it is. There it is, cycle stop. So in this case, we're looking for cycle start. Kind of, yeah. So that would take care of that part. If we refresh that. Well, I got a few more. Oh, no, okay. This is all about, 9 and 8, because 9 is a copy of it. We're not going to mess with that. So at this point, this one actually does nothing. So we could simply take that out, and we could take that out. And then that bottom row actually does nothing. I might need to check that one, but I don't want to go too deep into this. But yeah, at that point, cycle start, so we're going to extend the branch down here. Oops, I didn't delete that too soon. Extend branch down. And we change that to examine if open. And we look at that bit. Examine if closed. Then we could take all that out, and there you go. So I don't know that this is insanely simpler. I mean, I guess overall I would say it's cleaner. Might need to double check a few of my things here because I did just start to get really pissed. Oops, actually that. Yeah, there you go. That goes there. That comes out. So something like that. I would need to look at that. But yeah, you could do it cleaner. And I hear all the time that ladder, has been gone. But the thing is, when you're working on machines, and that's the thing, you got to remember, I do build some new stuff, but I'm the one that's out there fixing these machines after they've been here. And 98% of what you're going to see out there, I would almost argue 99% is ladder. So I've heard since the 2000s that ladder is dead. In fact, when I was doing this project, I never forget somebody came up to me and they're like, how are you liking this? RsLogix is fun. And I'm like, no, it's not. And I rambled off whatever the latest one is and that it was going to replace it. And here I am 22 years later going through this ladder program that is still relevant, and that programming software that I thought was the latest and greatest is dead now. So yeah, I hear that, but it's just not true. Is ladder the best programming software in the world? Absolutely not. Is ladder programming software that you're going to run into most in the United States? Absolutely. If you have a choice between learning ladder and function blocks and structured text, and you only could learn one in the US, you better learn ladder. But you should learn all three in every other language that you can. But yeah, if you're going to work on equipment, you're going to need it. And that's probably another podcast we could talk about that. Let's see here. All right, so there's the old program of that. Oh, okay. So can anybody guess what is wrong with this wrong? Like that and that right there. So I've added something here, and just judging by the way this is probably something that it was like, hey, this doesn't quite work right. We got an arm swing. It had to be on for 2 seconds before okay. I'm wildly guessing that we had some timing issue with it, thinking that the arm, because it had a carousel that had to rotate, and you had to stop it in the right position. But if you went out of position, it would have to alarm. And I get the feeling it was alarming sometimes right as it took off. But here I am, 20 years later trying to guess at this. But this should have been labeled as something like, arm swing. I don't know, overrun delay. And here I am 20 years later, not looking at the machine, and that's a total guess, but that would be that. And then, yeah, I have no idea. I'd have to go and figure out where in the world am I even using this, and let's see. All right, so it was some type of malfunction, and yeah, I have no idea. Arm swing malfunction that I can't remember. Is that what we should put there? So, as much as I preach it, there you go. I didn't do it. Arm swing, some malfunction. But I should have had something on it back when I did it. And that would have just made life so much easier. All right. We got a first pass and some other things. It'll do the cycle stop. And it looks like, all right, I probably missed something when I was doing that cycle stop earlier. So this probably, this probably ends up with some permissives that would be in rung 8 now. Let's see. Oh, yeah, you're right. So, yeah, I'm just catching up on chat here. And I used a handheld programmer one time, and that was, actually, I watched somebody use it. And that's when I was like, yeah, programming it for me. And really, I was not, like I said, I was not the person in school that, messed with PCs or anything. I never forget, I was like, I don't know, it was maybe 19 years old, and there was a super deal on computers, and it was like, you need to buy one of these. I'm like, what do I need a PC for? So it definitely wasn't the person that really that was into all this. But I do remember the handheld programmers, or those ginormous 50-pound interfaces that you had before laptops, and yeah, they were definitely painful. But okay, we have the MCRs. We already talked about that. Even here, I mean, let's back up a little bit on this MCR. Here's the issue, is if we go to the top of the MCR, where was it? So it had to be ready for this zone to work. Now one, MCRs only work on outputs, physical outputs. Isn't that right? Anybody remember? I didn't see any outputs in there. What does this MCR do? Use the setup area zones where all non-retentive outputs, which would mainly be your output energizers or OTEs, may be disabled at the same time. Yeah, I don't think that MCR actually did anything. I feel, we'll say 80% sure that this MCR is actually a total waste. Yeah, I have no idea. Here's where, I said me and my 3 hours of programming skill was doing the best it could. And probably in this case, the MCR did nothing, at least on that one. So maybe that's why I had so many MCRs in here, as I was trying to figure out how to turn something off. I have no idea. All right, same issue here. This timer's not labeled. Oh, okay, well, this is kind of an issue. And, probably, again, I probably didn't know. We'll have to go back at some of the other and look. But if I cross-reference T421, oh, it's used several places. But notice I did put a description on the .dn. And look here on T25, same deal. And all right, here's what I was looking for. Is notice here I described T4:12 and T412.dn. Either, why would I have done that? And maybe in the earlier RsLogix, or maybe somehow I turned it off. If we go to properties and go to a comment display, there's somewhere here about child elements, something. I have no idea where it is. Okay, but somewhere you can disable it, but mainly this no tire feed, I could Control X it, and I could have put it right here. And since it's on the parent element, which is T421, then it shows up on the .dn. Michael says we are buffering. What do I need to do?
I am.
You're buffering?
Yeah.
Oh, man. Are you streaming over there too? You watching YouTube? Okay, so I don't know. You guys in chat, are we having issues with buffering? Is this coming through pretty clear? Yeah, let me know either way, because apparently Michael, my streaming expert here, because I don't know anything about it, says that, yeah, he is buffering. Okay, Dyson says we got no lag. All right. Manim, I'm just going to say Manim. I know I'm sorry I'm butchering your name, but yes, it's good. Okay, all right. Well, it looks like it's just us, so hopefully everything is good. Okay, but yeah, so that would have made that clearer. And it looks like, let's go back to this one, because right above it I saw another one. And here's where I just really didn't know. Right here, if we go to, let's remember what rung I'm on. I'm on rung 17. If we go to 269, there's another one where the base element is not described. But here on 25, I do have a description. So that should have gone on T425 instead of T425.done. That would have made it just tremendously clearer. But okay, let's see, where were we? We're on 18. Okay, now what I'm seeing already with this, and this goes to needing these routines over here, is I'm a little lost myself on where we're actually at. But okay, we have a no tire feed, and so this means that, okay, there's no tire that's ready to go, I guess. But let's see if we can get into some of the meat of this. I'm going to skip through some of this. We'll come back to it. And let's just see if we can find how this thing works. Okay, so we have a main step here. I believe this is the main step that I was kind of thinking this should go into. Oh dear, we have, okay, well, let's see if we can get lucky. And if our MCR is the bottom of this main step, so we're on rung 37. Oops, and we're going to type MCR. And okay, actually, well, 42, that wasn't very far. What am I doing here? Oh, okay. Again, I wouldn't do it this way today, but this isn't horrific. All right, so mainly what we have here is main step 1 and not main step 2. We have this count bit right here, B3712. And then if we look right down here, there's that same B3712 that counts up a counter. Now first, this is unnecessary unless B3712 is used like 100 places. But it's not, it's used 2. So really this rung's unnecessary because really we have this logic up here that's turning on this bit. And then down here, we're using that exact same bit to turn on a counter. So I could have simply cut that, deleted that rung, and put this right here. And that would have made this a lot clearer. Now I can kind of see main step counter, and these are the things that will cause it to count up. And this one's a little confusing. What is up there? Well, you know, we're running into the same nested branch issue, and here's where, okay, I really, and then, you know, then this isn't something new. I have had people ask me this same question all the time now, is I did not know about this extended branch down. So, and this is actually causing a big confusing issue in this. Now again, I would not do it exactly this way today, but this isn't bad. This, but what's happened is I have 4 nested branches, which is the processor limit for this counter. But I have 5, 6, 7 steps that could increment this. So I've stuck this bit in here on one of them to deal with really the 2 extra steps. Man, how can I now here's where I would love, I don't think I can do that. Can I copy there to there? Nope, can't do it. Oh, this one's gonna be a pain to do anything with. Can I do there to there? Oh, we're gonna have to copy a bunch of numbers. I'm gonna get lost. So I'm not gonna do it that way. We are gonna move this rung up to here. And then, all right, and this is main step 2 and not main step 3. Man, it does go all the way up there. Isn't that a bummer? Well, we have 1, 2, 3, 4 branches. So I'm going to go right here. See, I'm going to stick a branch. First, we're going to extend this branch down, because this is what we should have done, is this extend branch. Let's see, let me catch up on chat over here. All right, glad everything's going good. Yeah, this, let's see. Yeah, I'm glad this is refreshing, because, oh man, I'm having flashbacks. This was terrifying. I mean, really, you go in there with a book and had to go learn how to program PLCs. And, you know, and I do agree. I don't do the sequencer instructions. So actually, and I'm getting ready to do some sequencing videos. I mean, and honestly, there it is, shift sequencer. But you know, you have these sequencer instructions. I'm just going to drag one down so you can see what I'm talking about. I'm just going to get to there because I'm not even going to use it. I don't like using these because they are so specific to AB. And there's a drum sequencer for Automation Direct, I believe. All of them have them, but they are insanely different. So when a technician is going to troubleshoot, they can be impossible to really follow. So I do like, I like what I have here. I'm not, looking at it, I'm not so sure I won't use this in a video of, hey, here's something else I did at one time, and there's nothing wrong with it. And depending on how our time looks, we may go through how to do it. But okay, so what I really need to do here is I need to drag that to there. Oh gosh, yep, I'm gonna get lost. Let's see if I can pull this off. That to there. That to there. And that to there. And then we can grab that one. And drop and drag can be your best friend in this as long as you don't drop it in the wrong place. That to there. There. And then this one here. And then we had a couple on the end of it. Oops, doesn't go there though. Where does it go? It's right there. I think I got this right. And you guys remember, this program doesn't actually have to run when we're done. So, so if I did miss one, it's not the end of the world, although I should try not to. Okay, that would take care of that. Okay, so now let's look at this. So mainly this is step 1 and not step 2. We're going to take this out in just a second. Then here we have step 2 and not step 3. Now looking back, I'd want this at the beginning, because when I get looking through here, I'm like, I don't know what's going on. But if I start with that I want step 1 and not step 2, that's going to make it a little easier to read. All right, so next we need step 3, not step 4. Where's that? That's right here. So we go up here to this one, and we find that hidden extend branch down. Maybe somebody can tell me, why is that so hidden? It seems like that just should be a really, I don't know. Seems like there should be an easier way to get this step up and step down. All right, so this is step 3 and not step 4. Step 4 and not step 5. Step 5 and not step 6. Oh, I need to extend these branches down though. That one's extended down. Extend branch down. Extend branch down. So then that, Control X, Control V, then this one Control X, and Control V. Step 5 and not step 6. Okay, then we need another one for step 7 and not step 8. Control X, is that all of them? Actually, I said step 7 and step 8. Is that what that is? No, that's step 6 and not step 7. Then down here we have step 7 and not step 8. Whew, that was a lot of work too. I think this will be, besides this rung's a little clunky now, but all right, so mainly now CU, let's make sure this, and here I am, I did not even think to check this, but I'm sure it is. Yeah, it's only used here. So really, if this bit was on, it was doing this one. So now we can take that out, and we take that out. And mainly we've taken 3 rungs that weren't super clear, and I think we've cleared it up here. It's a little long, if I had a bigger screen, this would work better. Oh, wait a second. These are done. If I clean up what's left here, that's not bad. It's close. All right, let me catch up a little on chat here. Let's see. Yeah, SFC's, SFC's, actually, I'm gonna review, if this works out well, I am gonna review some of my newer programs, because really one I just wrote, and I did nothing intentional, it's just the way it naturally happened, is, I ended up with function block programming, structured text, and ladder very commingled in the same program, and it worked really well. Yeah, well, and talking about this live stream, I'm glad you think it's great, and yeah, this may be a regular thing. We'll see just how it goes. let's see, question for Tim and most folks in the U.S. How much of a market share is AB versus Siemens with machine builders? And, you know, I just covered this question not maybe a month ago. Is even, you know, and I will say AB is definitely more dominant in the U.S. versus Siemens compared to the rest of the world. But still, there are regional areas where Siemens is prevalent. So you really have to, you know, the U.S. is a big place. So you've got to really focus on exactly the area that you're in. Some areas it's going to be busier than the, you know, other, or one's going to be more popular than the others. So it's a little too broad of a question there. Let's see. Control speed over VFD. We've got a couple on that. And yeah, let me just pop over here. Yeah, I mean, if y'all want, you know, if you think these live streams help, we could talk through something like that. But here, let me just post. This right here has all types of VFD videos, from how single phase works to how to wire a PowerFlex 525 drive to how to make a rotary phase converter if you don't have three-phase power. So there's some good stuff there. Let's see. What else we got? I know, Gillen, you know, I just did a video on this. Licensing is not nearly as expensive as everybody claims it is. And what you'll find, the people that are two people claim that licensing is outrageously expensive. First is competitors, and second is automation companies that want to make it out that it's much more complicated than it actually is. I just did a video, I mean, it seems like it seems like last week, but it probably was last month, that was talking about that for less than $500, you can be into the low-end Studio 5000. You know, Connected Components Workbench is free. I mean, there's a lot. Now, there is some software that, you know, you may end up $10,000, $20,000, but it's not software I've ever needed in my life. So you probably wouldn't need that either. Let's see what else we got. Well, hey, Zeus. Hey, from Mexico. Nice to meet you there. Okay, so we've gotten this down. What do we have here? Arm stopper. Step 5. Okay, this has to do with that. Okay, so the first thing I'm thinking here is this should have been, okay, we're still going. Because, yeah, I was sitting here thinking, how did this work? But, okay, I get it now. So we have step 1 and not step 2, step 2 and not step 3, and so forth. And if we look down here, if our main step counter accumulated value is greater than or equal to 0, we're going to be on step 1. Now, if you're greater than or equal to 2, we're going to be on step 2. Now, notice, if we're greater than or equal to 1, and this is probably why I did this, because I started getting confused. And this is why I actually would do it in a binary way now instead of this, is, yeah, counter step 0, or counter accumulated value 0, is going to be step 1. And that's why I probably put this truth table down here, is because I really couldn't handle that. Or I could have just named it step 0, but, you know, I was new to this, and I think I shared before, my poor kids, you know, they would come home in kindergarten so proud that they could count, and they would start with 1 and go up to 10, and I'd be like, where's 0? And they would just be completely confused because they don't teach about 0. So I probably could not conceive that we could have step 0 and work our way up to the steps. But okay, mainly here though, if it's greater than or equal to 1, we're going to be on step 2. But also notice step 1 is also going to be true. So that's why I have step 1 and not step 2 is going to be step 1. And that's what I've done up here. So step 1 and not step 2. That means we're actually on step 2. Now once step 2 is true, that'll keep us from looking at step 1. And yeah, so that's what all this is down through here. All right, then we got a main step reset. Now again, oh, okay, that's the beginning of an MCR. We don't have to worry about that, but I thought I saw an MCR in here. Did I see an MCR? Okay, here's an MCR. You know, and maybe this may be the only time in my entire program career that I used an MCR. And if I ever used it again, it's because I still didn't know what it did. But this MCR, I'm almost 90% sure now, does nothing because there are no actual outputs. I am not sure about this one. Anybody out there remember how the MCR works? I would never use this now. But okay, anyway it goes, this is starting to get really clunky. And okay, we still got some main step stuff going on. Okay, no, I'm going to cut it off right here. And I'm going to say this is our main step sequence. So I would take this rung all the way up through our new simplified rung, and I guess I will drag this MCR with it. I would Control X that, and I would put it into this main step routine. And that way, if I want to know about the main step, I could have gone over here and figured out what it is. Let's see, let's catch up here. What do we got? Yeah, there are a lot of softwares, you know, and I don't know, I can go either way on that because there's so many easy entry level ways, and I don't know all the, you know, mechanics of that part of why there are. I've heard support contracts are expensive. No, they're not. And it is, and here's where I just, you know, I don't know how many times I tell people a week, just go ask your distributor. I mean, they're actually usually pretty easy to talk to. Is support contracts are dependent on what you're actually needing support for. So I believe Connected Components Workbench, because yeah, that was in that same video. Let me even find that video. See if I can find it quick, which probably isn't so, but I just did a video and it seems like it was. Again, it seems like last week, but it might have been last month. Actually, yeah, I did one. They were talking about Studio 5000 Mini Edition. And I think in this one, I even show that, like, if you're starting out with Connecting Components Workbench and you're, oops, where am I? There I am. Lost my chat for a second. If you're starting out in Connecting Components Workbench, I think support for a year is like $150. So really, to be able to call and talk to somebody who can answer your question really fast, that's not a bad deal. You know, I don't think. And even, you know, if you're scaling up into bigger software, still, I think they bring more value to the table then. And I've changed over that over the years. Because, yeah, I was definitely used to be on, well, you know, I pay for the hardware. Why should I have to pay for the software? And they, you know, it was always like, well, no, the more I think about it, there's value in it. They're giving some good value there. But let's see. No, I don't agree with buffering inputs and outputs. And no, I do see some that do it. And really, it has to do with, I will say, not fully understanding the scan cycle and maybe writing a little bit more lightweight code, I guess you could say, is what I would call that. Now about the asynchronous and synchronous scan, the asynchronous scan is more of your control logics. So it's going to have an RPI for all of its different inputs, and they're not locked with the controller. Still a well-written program. That's not going to be a big deal. With the SLIC, in this case, what we're doing, we're going to have a synchronous scan. So PLC is going to read its inputs, execute its program, update its outputs, and it's going to do in that very repetitive fashion. So. Now, let's see. Curious if this applies to Micro 800 processors as well. Are you talking about the scan cycle? The scan cycle is synchronous on the Micro 800, so it does go through those 3 steps. But okay, we've gotten through that. Where are we at now? And here's where, yeah, you know, the biggest thing so far I'll criticize this program over is that everything is dumped into this single routine. This is really making life kind of difficult. And yeah, I'm still a little confused on the MCR, what it does, but all right, let's go on down. Here's another CU arm swing. Is this another one of those sequencers? Let's see, there's a counter. Okay, and in this case, there were only, well, 2, 3, 4. Well, there's step, I have step 1 and not step 3. So I blew past step 2 here, which is something you can do. If you end up not needing a step, then you can do this. But okay, same deal. Let's cross-reference this bit. And yeah, I shouldn't have done this because mainly we have an output energize on rung 48 and right here on rung 50, right below it with really no, no program timing issue. We're just using that for a counter. So in this case, I should have cut that, deleted that rung, and put that right here. Take that out, and there, that would have worked just fine. And good grief, we still have these MCRs. And yeah, even now I'm struggling to track these. But okay, we have an arm swing program. So over here, we would just call this, we'll just call it the arm step. And then, and then of course we need a JSR to it. So we go back, let's see, we're on around 50. Yeah, we need, jump to it. So that would take care of that. Now we can go back to rung 50, and yeah, really, from 49, yeah, we'll leave these out because I'm not exactly sure what's going there yet. But definitely from 49 to 60 was that arm swing sequence. So it could have gone right there. Tim, can you move your webcam feed to the top right? Your logo is over you and is driving me nuts. Well, I'll have to remember that one for next time. I didn't think about that that little logo down there, but you're right. It's probably in the way. And sorry about that, but no, I can't move it now. No, we're not going to do it. Yeah, Michael's getting ready to jump over here to save the day, but yeah, we actually have this stream going, and yeah. Yes, let's put that on the notes too. Do better next time. We will move us next time to. And really, in this case, usually the bottom right is the least used in most programs, and that's why I do it. But you're right, RsLogix, we could have been up here, and that would have been cool. What else do we have here? Let's see. I get a little bit here about, what is the order of features and capabilities, and from low to high we got slick, micro 800, MicroLogix, compact Logix, control Logix. Is that correct? I would not fully say that's correct. First you have the slick and the MicroLogix, and I would actually group those two together. They are the previous generation. I wouldn't use them on many new programs. Now, I mean, if you're making a cookie cutter, I say cookie cutter, not actually we're eating cookies, but if you're making something that you made the same thing for 30 years, you might still use it, but probably need to start thinking about switching to the micro 800, I would guess. I would say then I would group the control Logix and compact Logix together. And really then it comes to the scaling of how big your system is. So on a smaller system, you would use a compact Logix probably, where there's less I/O points, less Ethernet I/O, things like that. And then as it scales up, you'd end up in the control Logix. The micro 800, I would say is, it's a good, I hate to call it a basic workhorse, but it is a workhorse. It's really turning out well. I think these last few revisions of it have really improved it so much. But really, it's it's an economical processor that has a fairly large I/O footprint. Where I would say its cutoff is it's not real good at Ethernet I/O. So in this case, actually, what we got here, so we have a micro 800. We have a PowerFlex drive, and we have an HMI. And this is, all right, no, I probably should have probably should have prepped this a little more, but let me get the screen up here, since you know what I'm pointing at. But yeah, so this trainer right here, we've got a micro 820, we got a PowerFlex 525, and we have an HMI. And I would say you can do some basic Ethernet control. I mean real basic. I would not go far with it from a micro 820 to like this PowerFlex. So I can go from the HMI, hit the start button, which is going to go over here, this PLC, and then it's going to write to this Ethernet. You get a little whine there. Not going to do it for long because it makes really bad whistling noise on the mic. But so if I had two PowerFlex drives, or if I was scaling very much, I would quickly go to the CompactLogix or ControlLogix PLC. Let's see, what do we have? I've noticed some distributors sell MicroLogix for twice as more expensive than the 820, for example. Well, Rockwell is starting to phase out the MicroLogix, and I'm not going to do it here, but if you will go to, actually, if you'll just go to ab.com and look up a MicroLogix part number, you're going to see that it is an active mature status. And what that means is it is still fully supported, but it is no longer going to have any additional features added to it. And the Micro 800 is the newer, or it is called active. So that means it's also fully supported, but they will add new features to it. And they are trying to get you to shift to the Micro 820. Now, they don't want to just immediately say we're not going to sell any more MicroLogix, because that could cause people to go somewhere else or get upset. But yeah, pushing the price up will help you shift you over. And yeah, if you do not believe that they want you to go there, just buy a MicroLogix 1100. It's got a sticker right on the front of it now that says, go look at the Micro 800 series. That's a pretty good indicator that, yeah, they're going to want you to shift to it. Let's see, will this video be viewable afterwards? Yeah, if we do not bomb horribly tonight, then yeah, this video will be viewable afterwards. If it starts going to pieces, then yeah, I may take it down. I'm not, this is our third live stream. And our second one was to try to fix our first live stream that didn't go that well. So we'll just see how that works. So this one's from Tim. Have you come across much OPC UA yet? Does it cost anything to use it with Rockwell PLCs? Well, usually there'll be some intermediate software, and there's many ways you could do that. Some of them have something built into it. It just depends on the exact situation. Kep Server is one that's big on OPC UA. There's lots of them out there, but there is no, you'll have some intermediate thing usually, and I say thing because I can't think of the right term on the fly here. But yeah, I do run into it. I do have to do it, especially, on some of the, data acquisitions where you're integrating with some supervisory network, or maybe you're going into some OEE system that's doing some type of, equipment efficiency calculations, things like that. Yeah, it does happen. That might be a good video. No, that's a little out of my scope usually. Like I said, usually mine are more on how do we keep the machines running, how do we hit the basics. I'll have to think about that one. All right, let's just go on. So we've got. I'm not gonna simplify any more of these, but actually this is a good one. As soon as I say that, arm swing OK1, arm swing OK2, arm swing OK3. What am I doing here? Let's cross-reference this. Using it in 45 and 256. So 40. Oh, I need to refresh my. One thing, if it looks like all of your references are way off, as I've added rungs, this doesn't automatically refresh in RsLogix 500. So when I hit this refresh, it's going to go to 46, which is going to make a lot more sense. Arm swing OK, arm swing OK 2. I don't know why I broke that up, but there was also an arm swing OK 3. Oh, thanks guys. Yeah, thank you. Chat is working very well for me because yeah. Well, you said you didn't like me being down in the bottom right corner. It was driving you crazy that the logo was over me, so I was just trying to help you out here. But okay. Let's see. So let me go back where I was. Let's cross-reference this. And then we'll go back to our outputs. So yeah, as I was scrolling down, because I'm not going to simplify any more of these sequences, we're just going to throw them over and get, because one thing, if you notice, there's not been any outputs yet, which is kind of interesting. I think I probably should have an output area, but it does look like maybe I grouped my outputs together. But I was looking, I've got an arm swing 1, and I've got an arm swing 2, okay, and I've got an arm swing 3, okay. I'm trying to understand why I broke these up and what they do. So like if I cross-reference this one, it's used in 55. Oh, well, okay, that's really weird. So, okay, here again, we have arm swing OK 3, and I cross-reference it. It is only used in 55. So really, if neither of these on, then it's going to put a 1 here, and we're just looking at it right there. And there's no, yeah, that's looking for a 1. That would make a 1. So really here's another one of those times that I could have cleaned this program up a whole lot. I have no clue why I did this, besides the fact that, yeah, you know, my 3 hours of PLC program experience for this may have been faltering a little bit. All right, but then, okay, we have arm swing OK 2. And I cross-reference it, it's only used on 46. Okay, and there's 46. We got arm swing OK 2 and arm swing OK 1. So unless, maybe is this one used somewhere else? Cross-reference. Okay. This is done well then. I was getting ready to get on myself because, whoops, wrong one. Mainly because I had that broken up. Now that 3, it didn't need to be there, but these do, because apparently I have 2 different situations, and one of them, a lot more stuff needed to happen before it went. Not really sure there, but okay, let's see if we can scroll down and find some more of the meat. Okay, well, here's our feeding step, and we've kind of gotten the hang of this now. So cycle start, there's a crazy MCR again. And, you know, actually, you know, now that I think about it, I really think this may have set all these to 0. It does. An output is an output. An OTE is an OTE. It doesn't care what box it is. Much as I preach that, that would mean that an MCR it would set all these to 0 through here. Still, this is a really bad way I did this. I mean, there's no doubt. If there's anything that's really just glaring at me right now, it's these MCRs. But okay, we're going to go down here through all this feeding step stuff, because I think we've covered everything we can on that. Mainly to right here. We're going to go up. And you can see, these are the same things. I didn't know how to do the extended branch down thing, so we ended up with 3 feeding steps. All to go to one timer or counter. Okay, mainly we're going to go to there. We can look at that when we get in there. So Control X. We have a feeding step here. Control V. And yeah, same situation as before. I have feeding 1, probably 2, probably 3. But yeah, well, no. Okay, one of those wasn't used apparently. This may be worth going through. Why did I do this? We have B310 13, B310 14. There's 14. I have no idea what that is yet. There's 13. Oh, and look, there's B3914 and there's B3914. I think all this still has to do with me still not understanding these extended branches down. So if I cross-reference this, then yeah, it's just used right there. So really, using the extended branch down, I could have combined these 3 rungs here, and we could have moved this counter up to it. So 4 rungs would have gone to 1, and that would have been way cleaner. All right, where are we at now? Oh, but you know, really the big thing I'm seeing is, yeah, this is still lacks a tremendous amount of organization. But okay, here's our arm swing. Have we not done our arm swing? I thought we did our arm swing. Did an arm swing. So here's where, yeah, the grouping would have been great because, oh no, this is the gate. So blank, yep, blank on the gate. So again, I'm not going to go far into the gate because I think we figured out the shortcomings of my sequencing. We're just going to cut that out, put it into the gate step. See what else we can find. All right, there's our paint step. Have we not found it? Yep, okay. And same situation. I do not know what I was thinking with these MCRs, but you know, they're here. Oh, this one's different. Step 1, step 2, and then we got some tire sizes. Holy moly. Oh, and then we're, all right, so all this is the paint step. So paint step really goes through, oh, it goes a long ways. About there. So Control X. And what was that? Paint stuff? What did I just say? Michael Paint?
Yeah, you're talking about paint.
Paint.
Our mind was on food.
Yeah, Michael's over here holding up a sign asking if he can get food. I'm like, no, I'm going to be like drooling here again. Okay. Now we go back to the bead stuff. Now already, the big thing with this so far is we've taken, I mean, it's still complicated, but we've knocked 100 rungs out. Okay, and now down here we do have some outputs. So there's a couple ways we could do this, because this is probably what I'm seeing already is a difficult part about this program is it is so long and so scattered that it's really good that that hasn't had a lot of trouble over the years, because this would be just near impossible to troubleshoot. I mean, I'm sitting there thinking, where would I ever begin in troubleshooting this? Look at this. Yeah, it just continues to scroll and continue. Okay, well, wait a second. What is this?
Oh my goodness.
Okay, well, no, I am going to take back everything I just said. Now, this is kind of, I'm surprised. So down here, I have grouped these. I'm guessing this does nothing. Let's cross-reference. When I say does, I know an output energized does something, but cross-reference. 222, 233, and 244. Okay, so I did something that typically I would say is a no-no here, but it works perfectly fine here. I have monitor 1, and it's used in rung 222, 233, and 234. And all I'm doing here is I have made it where you can view all that stuff that's scattered throughout the program in this one area. So we can see what stuff the arm swings on. We can see what stuff the feeding step's on. What step, I don't know why I broke this up. Oh yeah, I do. And here's, yeah. Here, all right, everybody who says you know that duplicate destructive bits are illegal and all that stuff and you shouldn't do this, here's a perfect example of, yeah, there's nothing wrong with what we're doing. Now, here's why I did that, is that makes it look a little confusing, and probably I was on a little laptop. I could have done that. I'd argue that either way today, but yeah, this way you could see exactly what step each one was on. I mean, here's our main step. Here's our paint step. Trying to think of what this is. Inner diameter, height. That's how big the tire is. So, I guess we had small, medium, large tires. Inner diameter, yeah, 15-inch, 16-inch, 17-inch tires, probably something like that. That was probably the rim size. And then you had a height, and that probably had to do with the thickness of the tire. That's pretty good. You could do a lot with that. Okay, so I take back what I said, but all right. Here we are again. We'll just start down here. We have input number 7, and what is this? we have something, we have a rope switch, or conveyor 1 is running, then we're going to turn something else on that we haven't labeled. So this was probably a last minute add. Also, yeah, while we're here, make sure I understand this. Wait, what am I missing here? What's different about these two? Oh, this one's bit 1, this one's bit 0. I have no idea. Tire at conveyor 1, run conveyor 1. Tire conveyor 2, run conveyor 2. Okay, this is something similar. This is another sensor. It was probably added. Maybe this is an additional conveyor. So, I mean, and again, I'm going to throw a crazy description on this, but actually it's just another conveyor. But yeah, so this was probably added last minute, and this is very unclear. But okay, I could do this a couple of ways. And mainly from a troubleshooting standpoint, I'm going to this subroutine over here, is if it's a simpler program, usually I will group my stuff. So I'll have, maybe I'll have one that, if there's a lot of analog, I'll have one subroutine is just for scale, and just group all that math and all that crap that normally you don't have to look at, just group it all in one spot. And then maybe I'll have one that is a sequence. If it's a batch sequence, or if it's doing something like this, I would have one for it. I'd have one for all my outputs on a smaller system. All my outputs would be grouped in one subroutine, because really when you get the call in the middle of the night, you're never going to call saying, hey, my gate switch isn't working, can you come fix it? No, it's going to be, hey, my motor won't run. So I want that output where I can easily find it, and I can work my way back and find that gate switch. Then I probably would have some alarms. It looks like we have some. So we do have some subroutines to add, but I think this one is segmented enough, and routines are cheap. I think I would have one that says convey output, or out. Conveyor out. And obviously we have some diagnostics now we found. So I would make another one that says diagnostics maybe. And let's see, actually let me finish my thought here, and then I realized, yeah, I kind of missed a few chat things here. Let me get back to those. Okay, so these are definitely diagnostics. So these are used on up too. We're going to have to go figure out. Oh, come on, guys. You got to tell me. I'm sorry. I forgot to switch back to here again, didn't I? Oh, man. Okay, so what I had said there is we had enough. We needed to group some more stuff together. And so I got a conveyor output routine here now, and I got a diagnostics routine here now. And we know that these are diagnostics. So we're going to take these. And actually, honestly, these diagnostic ones I would leave in the main routine. And, honestly, I would. Because later on, if it's not me going in here, we'll leave this here because there may be some reason for it. But later on, if I'm not the one that goes and looks in here and I start scrolling, I'd like for these to be a main routine, because I think they would get down here. And I very quickly was like, oh, this is some type of thing that I can follow these steps. I think somebody else would too. But all right, we have these conveyors, definitely. Got an exit conveyor start. And gosh, there's another one of those MCRs. Let me make sure I grab that MCR in this. Hey, I would not, absolutely positively would not do the MCR like I have it here. But it is a program instruction. We should know how to use it. And even now, I'm kind of scratching my head. So I probably should learn a little more about the MCR, or brush up a little bit. Also, when I did this, I forgot to add our JSRs to these. So I need to scroll up to the top. And yeah, we need 8 and 9 now. So U8 is going to be our conveyor outputs. And number 9 is going to be our diagnostics, which is empty right now, but I bet you we'll run into something. All right, let's catch up a little bit over here. What did I miss? Oh, Roberto, how's the Plymouth going? Well, the kids had to catch up on some schoolwork, so yeah. Hopefully we'll have some updates on the Plymouth soon, but yeah, their education got in the way of them learning. You gotta hate it when that happens. Yeah, okay, did I fix the full screen? Yeah, we're fixed on the full screen. Sorry about that. And yeah, can the counter count up unless false true? Yeah. Okay, the way this was written, did we leave any of those? We left some of those. Anybody remember which one we left? Is it this one left? That one's combined. Michael is saying I need hydration. He's been hanging out with mommy too long. So yes, I'll have to stop and have a drink of water here in a second, apparently. One of these I left. This one. Okay, so let's talk about this. So really, first you're right. If this one was true, and then this one fired while this one was true, in fact here, let's just right click, toggle, or where's toggle? Am I blind? Well, that's toggle not there. Is it not there when you're not online? Well, I'll fix you. Go to data table. We stick a 1 there. Oh, it's still not going to show. Okay, well, yeah, well. Give me a second here. I'll get there. Not worried about the errors. But you're right. So, first let's just get everybody in the same place. This says, can the counter count up unless false to true conditions occur from each branch, thinking out loud. So right now, this instruction is true. And this is going to enable the CU bit right here. And this is how the counter actually tracks where it's counted. And so if this becomes true while this is true, the counter will not count. But if we think up a little further here, we have this step 4 and not step 5 and not step 6 and not step 7. So at no point can both of these be true at the same time. So this will always work with this branch here. And when we go up here and we put all 10 branches in here together, then it will work just fine as well. So both of these will work. And yeah, just mainly that'll combine it all into one. Now, but yeah, if for some reason I didn't have step 1 and not step 2 and not step 2, or I had any situation that 2 branches could be true at the same time, the second one that came true would not count that counter. But I think this is actually, I'm kind of surprised at this. Again, I would not do it exactly this way today, but I would knock somebody who did it this way today. Okay, and I think, yeah, we're kind of talking about edge trigger there. That's what we're talking about. Except for it's not, it is kind of edge triggered. Now, I don't like using the word edge triggered because really, if the conditions preceding a counter are true, then it's going to look at the CU bit to determine if it's going to count up. So if the conditions are true and the CU bit's false, it is going to increase the accumulated by 1, and it's going to write a 1 to the CU bit. And that way, next time it comes around, it's going to see the CU bit is true, and it's not going to count. But yeah, I mean, I guess it's an edge trigger, but I don't like words like edge trigger because they're, yeah, I hear people say it and they act like it's magic out there. It's not magic. It's looking at the CU bit. So yeah, but yeah, and for the most part, it is that. Do you think you made it easier before? Michael, you got to write bigger or something, man. I have no idea what you're talking about. Michael has made a note of something I need to do, but I missed it. And it's probably about him needing pizza or something. But okay. Well, Ahmed, thank you. I hope this is helpful. Let's see. Losing JM. Good evening. I left you a message prior to starting. If you go back to the BOD, is there an answer hanging around somewhere? If you go back in the BOD, missing what that is. But okay. All right. Okay. Where were we then? So we had grouped some together. Okay. And we had just talked about that. We were kind of working the bottom up now. Here's where, kind of having to chop away at this program now to try to figure out what it's doing. I probably would leave this in here like this. I probably would leave it in the main routine. Now this mischunk, I think this has mostly to do with our main sequence. I'm really not sure on that. And like I said again, okay, this is our second run. I will say, you know, talking about the latch and unlatch, there's nothing wrong with the way I had it, but even browsing, this really quickly and crisply, it was clear what it did. This one's still clear, but it's still a little more clunky. All right, and then we had some arm swing. We've got some stuff there. Let's see if we can get back into some of the meat. What is this? All right, Michael is saying I need a water break, so hold on.
And VOD is pronounced as VOD.
Okay, water break had. We're good to go for another hour. All right. We are setting some timer presets from somewhere. And we're going to cross-reference this. And these are not, okay, so I don't remember it, but this must have had some HMI on it. So these values are being written from an HMI. And here's where, yeah, pictures will be awesome today, but I don't have them. But okay, and they are grouped all together nicely. But here, yeah, we okay, so at this point, we need a routine. Now, you know, I'm adding these routines just as we run into something. I would never do this way. I would have some space in here, and I would group these kind of in some order to what they do probably. But okay, so we would take all this HMI stuff, cut, and we will put it into this HMI directory. I might would merge the HMI and the diagnostic now that we know it has an HMI. Yeah. Now I'm curious. I remember when I was cross-referencing that at the bottom, there was something else. Oh, we're going to go back and look at this in a second. But okay. So now we need a JSR to that one. And so this is going to be our HMI. Also, yeah, I try not to throw acronyms out there, but I did just throw that one out there just like that. HMI would be some type of touchscreen interface where we can tell the operator things. Or in this case, I guess we change timers on it, which are probably having something to do with the timing in the machine. Yeah, and yeah, again, I haven't looked at this machine in well over a decade, so it's fairly fuzzy. But all right, so we've got that. Let's see if we can find some other. Huh. Now, this will be interesting to revisit later. Is there some timing things going on here of when we can capture something? Yeah, so we'll come back to that. Not sure what's going on there. Oh, here we go again. You know, last minute, threw a description, I threw a timer in because it needed something. And yeah, I'll come back later and add a description of that. 21 years later, 22 years later, however long it's been, yeah, it's still sitting there with no description on it. So, I mean, that's why I always preach, you know, document your programs. All right, let's look at this MCR. This one better not be back-to-back. Okay, this one is cycle start, and this one is ready. So they are different. I do not like the way this MCR is done, but it is done that way. So, oh, what do we want to knock on next? Okay, that was arm swing. Okay. I'm trying to get to some outputs, some things that do some action, and we can kind of talk about some of that. Because really, I'm scrolling through a bunch of stuff here that I'm never going to be really looking at until we're further down the problem. Right now, I mean, like I said, it'll be some motor. They're going to call and say that it isn't running because something. But they're never going to say it's not, you know, they're never going to tell you the input is not going to run for. So that part I definitely didn't do a good job at in this. Okay, well, gosh, here's another one of those. Oh, I have no idea what that is. Oh, we have, this has a cleaning step too. All right, well, there we go. We know how to get, I mean, so what I'm doing here really is I'm just trying to knock out the things that are clean step. And we kind of know, let's see, start cleaning, no tire cleaning, cleaning count. This definitely has all to do with cleaning from 105. And we're going to get all the way down to there. Control X, cleaning step. Control V. All right. Okay, we finally found an output. And I would love to remember what JIP stood for, and I bet it's something really obvious. And it does say gun up here, so that JIP, didn't I just say gun, upper limit, gun something, painting, probably something painting, I have no idea. But this is definitely the paint area, and how can we tell it's the paint area? Can't really. Maybe that's not. Gun up, gun down. All right, well, there we go. There's gun down. There's gun up. Cross-reference. Let's see if we can start figuring out how some outputs work on this thing, because I think I did something not great here. Okay. So during paint step 4 and not paint step 5, which pretty much means paint step 4, 5, and 6. And if there's a tire there, we're going to raise the gun up. And one, 2, 3, or 7. So yeah, really, when we're not going gun up, in the end, if we're not going gun up, we're going gun down. So this definitely can be simplified. But all right, let's cross-reference this. This, I better not be using this in just one spot. Okay, good. At least I'm using it in 3 spots. Now, still, I don't think I'd do it this way, but let's look at it. So we have gun up to very small. So this has to do with tire size. Okay. So, how would I do this today? I would leave this in here, but I would not have this gun up and gun down. This is definitely wrong. Because I've overcomplicated this. Because this, if we go not looking for this, it's the same as this. So, let's see where all I use this. Okay, and I used it in 3 places. There you go, the gun down. So really, this should have been not gun up. So if we go up, is the next one gun up? So B310. So really, here's one of those times, and you know, I probably did not fully understand that this instruction really is a go look for a 1, and this instruction is a go look for a 0. And you know, like I said again, my 3 hours of programming experience before this job just may have not quite been enough to be thrown to the wolves, but we did make it through it. So this, we changed those. Then we refresh that. B311. Oh, missed one. Oh, forgot to change that one. So if I change that to 0, then yeah, so there's a lot of redundant things, and here's the biggest thing I see. So now that completely can go away. And now, yeah, if the gun's not going up, the gun's going down. And probably, even now, I kind of don't like, oops, I just did something wrong. No, I didn't. Yeah, then this is so much clearer. So during step 4, 5, and 6, if we have an overrun and there is a tire there to paint, we're going to raise the guns up to paint. And if we don't need to paint, we're going to put the guns back down. So that really is pretty clean. All right, so we have, let's go to find some, I don't like, I mean, if there's anything so far I'm very critical of, is that I I did not make the outputs really obvious. They are scattered all through this program. But this has to do with painting. And mainly the biggest issue here is gun up. We're using a rung 112. And we cross-reference it. It's up here on rung 73. So, especially if you're not somebody who uses the cross-reference a lot, I mean, you're going to scroll from 73 all the way down to 112 before you ever find this thing. So this rung should have been right above it. I mean, so really, I would go here, and I would Control X that rung. I mean, and I see what I was doing here. I was trying to group together things that happen. I think I am onto something here, but I didn't get this part right. So, I mean, today I would get that out of there, and I would go down here at 112. Even though I know it's used 3 times, this is really close to where it's used, and I would put it right there. That way gun up is right there, gun up is right there, and where else is gun up? Isn't it right below it? Let's see, refresh. So now we're at 112, 111. Yeah, so now we're all in the ballpark of where it's at. And I mean, it's kind of grouped together. And so that's what I usually see in most programs. And I'm definitely have done this a lot in this one is we scatter, you know, and here I have 300 rungs of scattered logic. And that is not working out really well for me. Let's see. We have... Yeah, and I probably shouldn't use whatever this acronym is because, I don't know, it'll probably come back to me really fast. But I have no idea what GOP is now. Probably meant something to me then. Oh, let's just go in here. Yeah, we're kind of, you know, and as much as I get on people about scrolling up and down the programs, that's kind of where we're at now. Is trying to figure it out. I did want to go back to this monitoring because I seem to have caught something. 195, 196. No, okay, they're all right here together. Monitor 2, monitoring 3. Yeah, actually, I'm kind of happy I did something like that because otherwise, I probably had to figure out how to do that for my own sanity. Huh. Okay, now this might be, what am I doing? What is this? Main step 4, one-shot rising, bit shift left, but I'm doing a bit shift. Why am I doing a bit shift on an input? What is going on there? Oh no, okay. I'm tracking. What am I tracking here? Oh, well again, okay, now in this case, it's not that it's not, although yeah, this rung may have needed commented. We haven't really ran into a rung that needed commented. Tire at chucking position. So in this situation, you didn't wait. If there was nothing to go to the, come into the machine, you still had to keep processing what was already in it. And so I am tracking the position of the tire, of the tires at the station. So actually, if we cross-reference this, then, whoops, missed. It shift left. B3, 17, so here you go. So this, you know, we haven't, I'm trying to think, do I have any videos talking about bit shifts? I can't think, I don't believe I do, but this is a good example of a bit shift. So if we just, let me kind of sketch out here, because yeah, I haven't fully explained what's going on here. And I may not get the exact number right here. But really, this is pretty much a carousel. Yes, this is my crude drawing of what we're doing here. But so a part comes in here, and it gets grabbed here. And really, this station is just to put it on a chuck, and it rotates. And I'm not going to remember, although it's kind of coming back. It seems like there's a cleaning step here maybe, or maybe there was some step there. and it rotates over to another step, rotates over, does another step, rotates over, does another step, rotates over, does another step, and goes out. Well, in this case, obviously, we're doing some painting, we're doing some cleaning, and you certainly don't want to paint when nothing's there. You don't want to really waste time cleaning when nothing's there. So we need to track whether there was something to go in on here before this carousel rotated. Because in the end, you could end up with a situation like this where we have nothing here, we have something here, we have nothing here, we have something here, something here, something here. And that's what I'm doing here. So main step 4, now we're going to find out how good my main step descriptions are. So if I've done this well, I could go find main step 4 and not main step 5 and see what conditions are with it and figure out kind of how this works. And here's where it's going to be a little weak on this because, thank you, Michael. I got to get used to having to click back and forth here. But okay, what I was saying is right here, we have when main step 4 happens, so at the one-shot or at the very beginning of main step 4, we are checking this input. When this input is there a tire, cross-reference, oops, not cross-reference, we're going to get a description of it, is there a tire at the chucking position, which is that first position. So if there is a 1 there, it's going to shift a 1 into this B317. Now my length is wrong here. So we'll look at that in a second because there wasn't 16 stations on this. We'll have to see how I dealt with that or what I did. So mainly, all right, first, when does it happen? And here's where my setup here is going to start to falter. Is what I want to do is I want to right-click cross-reference this and be able to quickly figure out what the main step does. But the issue you're going to have is we have 4 different places looked at for a 1. We have 1 that's looked at for 0. Now I'm going to actually look at the 0 one because I've kind of caught what I'm doing. But it's not easy to find and follow. And I could do this better today. But if we go to this one, and mainly I'm going to go, so step 3 is not step 4. No, this is funny. This step's been taken out. So the way this is going to work is the moment that this becomes true, it's going to blow right through and index to the next one. So it was this one. So main step 2. So, and here you go. There's that no tire and painter. So now we're figuring out, are there tires in there? Are there things in the way? And the moment that we figure out that we're all good to go and either we've chucked a tire or whatever, then we're going to go down to, where was it? Not going to remember now. It wasn't that one. Need to find that bit shift left. Let's see how many there are. ESL. Okay, there it is. So that moment, it's going to do this. Now let's look at this because I have 16 bits of length. So that means it's taking up the entire B317's word here. So cross-reference. Oops, I'm going to go to data table. Go to data table. And now we're going to go to a binary radix and we're going to hit the usage. Okay. And so what I did, and here's what I was, okay, there was only, you got to write bigger, man. I have no idea what that says. Or less words. Michael's giving me messages of things that I apparently am messing up on. No. In chat, what am I messing up on? Can you tell me? Because apparently I'm doing some things wrong. I have no idea what they are. But yeah, he's hungry. He's tired. Whatever. He's probably something. You have to feed him every 20 minutes. That's the only thing I know. But okay, so in this case, there were 5 stations. And so the links should have been 5 over here. But I have no idea why I put 16, except for that, maybe I thought you had to, or maybe you do. Not really sure. But okay. There's a cool thing of a bit shift left. So is there a tire at the paint step? Is there a tire at the arm stopper? Is there a tire at the blower? Is there a time at the put out step? So that's what that's kind of doing there. So All right, well, Gillen, thank you so much, and I'm glad you love this format. And okay, I will see you on the next one. Thank you so much, everybody. Gillen did do a super chat there. Super appreciative of that.
Whoop, whoop.
And yeah, so that is how a bit shift left works. And I will have to, Michael, put a note down there to look for a bit shift left and see if we have any. I don't think we have any lessons on this. We should hit this. All right, so okay, look at here. Now we're actually getting into some meat of this program. Tire size 14, tire size 15. Now I'm going to tell you something. It's coming back to me a little bit. These are indicator lights. This is not clear that this is an indicator light, but this is an indicator light. So I should have labeled these better. I mean, there's no way of knowing now, besides the fact that all of a sudden this panel is starting to pop back into my head here. But all right, let's see what else we got here. We're tracking some cycle time. Indication cycle. BCD. What am I doing here? BCD. Well, BCD is usually going to be some type of binary output for a digital display. Again, no labeling. You got to love that. TOD to BCD. Source. We're moving B318 to this. Oh my. All right, so I didn't do a good job here, guys. Oh no, wait, okay. This is cycle time. So if the cycle timer is running, we're moving that to that. The moment it doesn't, we move N718. I mean, do that. Oh, so I'm capturing cycle time here. This is how fast we were able to get a part through this machine. And where'd the BCD go? Anybody know where it went? Cross reference. Okay. Now this is horribly labeled again. And that's I'm going to knock this program for two things, and then we're getting ready to end this up here too, because apparently Michael's hungry.
I'm good.
But output 15. Okay, let's just go to data table of output 15, switch to binary. This is really poor right here. So output 15 is a BCD display, and that probably warrants its own video. This is a binary kind of thing that you can use, that you used to use before we had a lot of networked type displays, as these 15 bits would be used to tell that a number, in this case cycle time. But I have that labeled in 0A. I've got some of the labels of, these were actually the wire numbers, which is kind of a good deal. But even then, I didn't do a good job at that. So yeah, I did a really poor job at labeling this program. Although I gotta admit, overall, you gotta remember, there was three, let's face it, I have 3 hours of program experience before I did this 300 rung program. Overall, I can't say it's horrible, but it looks like as I was getting to the end of the project, and this is probably typical of any today project, as you get to the end of a project, all of a sudden you just really start petering out. It looks like I started throwing a lot of stuff at this to make it work. I did make it work. I'm still programming PLC, so that was a good deal. But really, I would knock this program for not thoroughly describing. Also, I did have some routines that needed commenting. So, you can comment instructions, but you can also comment routines. I should have commented a lot of routines here. And also, I will knock myself for having 300 rungs of unorganized logic in the main routine. This should have been broken up into probably 10, 20 subroutines into some type of organization.
And that would have made my life easier. Probably, well, it would have made my life easier today if I knew 20 years ago I was going to be doing a video on this, I would have. But also, probably when I was writing it, I have no earthly idea how I kept track of this. Oh, I did have a 20-year younger brain then, and I gotta admit, I watched what people can do today, and it is amazing what you can do without a pencil when you're, 20 years younger. But I gotta write it down now. There's no way I could have followed this and pulled this off, I think, today. But what do you think of this format? Has this been good? I mean, do you enjoy this? Did you learn anything? Would you like to see it again? Like I said, I've got one on a CCW that kind of mixes the data types I thought would be good. And I might be willing to review your programs. My big worry about that, I'd never like to criticize people's programs. I think, if you have a program that actually works and isn't quirky and does the same thing day in, day out, it's hard for me to criticize it. I mean, I'm more of the encouraging person, but it might be something we could do. Also, Gillen, yes, thank you for that super chat, and thank you to my Patreon supporters who really support kind of these odder videos that aren't, I guess, things that we're normally producing. So I hope this video has been helpful. If it has, please hit that like button and subscribe. And yeah, John Cunningham, yeah, we as long as you guys like it, then yeah, we will keep this coming. Hold on, we got one more. What's this at? Interesting format. Okay, Tim, I'm glad that you think it's an interesting format, and we do give preference to people named Tim just because I think it's a really cool name. So I will put double emphasis on your comment. And yes, please hit that like button and subscribe to our channel. Till next time.
Goodbye.
Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!